When a cartridge weapon is discharged, a number of forces are generated and a great deal of energy is released. The idea of using these forces or the energy in order to cycle the weapon surfaced in the 1880s. Though many people worked on putting this idea to use, such as McLean, Lewis, and Hotchkiss, I would like to concentrate on two major contributors whose designs made a mark on the course of warfare. These are Hiram Maxim and John Browning. Maxim harnessed the recoil forces generated upon discharge in order to cycle the weapon. By the 1880s, he had some practical designs. Though they worked reasonably well, his automatic weapons became what we understand to be a machine gun only after the introduction of smokeless powder and jacketed bullets. You have seen these developments in a previous tape. By 1893, Maxim was selling perfectly functional machine guns. Among their first recorded uses was action in the Matabele War of that same year. The painting Brave Men depicts the death of Alan Wilson's Shangani Patrol. The patrol was an advance element of Forbes's mobile column. After the Nabili had annihilated Wilson, their 7,000-man army advanced on Forbes, who credited his salvation to the Maxim machine gun. Maxim worked at refining his designs, and by 1908, the Maxim machine gun had been adopted by Germany and was made under license there. The same weapon was adopted and manufactured in England, where it was known as the Vickers. John Moses Browning had been working on another method of cycling an automatic weapon using the very same gases which propelled the projectile. His first workable designs were made by Colt Marlin and used in the Spanish-American War. When the bullet passed a hole or gas port located underneath the barrel, gas escaped and pressed on a lever. The lever rode all the way back and then was pushed forward by a spring, thereby completely cycling the weapon. For obvious reasons, this gun was nicknamed the Potato Digger. As war clouds loomed, Browning quickly branched aside and designed a machine gun using Maxim's short recoil idea, since short recoil was a good bit more compatible with water cooling. Without getting into French or Austrian variations, you can safely assume that every major combatant in World War I entered the war with a machine gun. The capabilities of all of them were quite similar. I will use this Browning 1917 water-cooled as a good example. Most of these weapons fed from a belt. As the belt was pulled through the machine gun by these feed pawls, individual rounds were pulled back out of the belt and then positioned on the bolt so that they would be next in line for chambering and firing. The Browning and the Maxim worked on the short recoil principle. In this method, the barrel, bolt, and barrel extension remain locked together after discharge and travel a short distance to the rear. After the bullet exits the barrel, the bolt then unlocks, sliding independently to the rear. The bolt comes back far enough so that the old cartridge case is extracted and ejected, and the new cartridge is placed in position. The bolt then travels forward, chambering the cartridge, and fires again as long as the trigger is held down. The Maxim, Browning, and many others were water-cooled. The barrel was surrounded by a water jacket holding approximately 5 quarts of water. After 600 rounds of continuous fire, the water would be brought to a boil, and steam would exit through a steam bleed-over valve down through this hose into a condenser bucket. The second assistant gunner kept refilling the jacket as water would boil away at the rate of 1 quart for every 250 rounds. Though the water did boil away, it was recovered in the condenser bucket. It also stabilized the operating temperature of the weapon and allowed continuous, sustained fire. All of these weapons were extremely accurate and fired their rounds into a very small group, which, in machine gun terminology, is called the beaten zone. As an assist, they were equipped with a micrometer traversing and elevating mechanism so as to enhance their long-range accuracy. They also were chambered for the full-powered rifle cartridges of the nations involved, such as the 30-06 or 8mm Mauser. Let's see what this Browning can do. In its first target run, you'll see a silhouette target on top of a 4x4 fence post and 2 real sly buggers hiding behind a cinder block wall. That's pretty impressive. The Browning fired such a small group that it had no problem cutting down the 4x4 post in short order. Both the wall and the 2 guys hiding behind it took a severe drubbing. This latter target illustrates a point. A wall, unless it is solid masonry, is no real protection against small arms fire from full-powered rifle cartridges. Next, we'll engage a group of targets in the open using the traversing and elevating mechanism and the final assault of targets on line. See if you can spot some advantages and disadvantages of the water-cooled. The advantages of the water-cooled machine gun are quite obvious. It is extremely accurate, can fire at very long ranges, and has a very high sustained volume of fire. In fact, the water-cooled machine gun is unique among machine guns in that its sustained volume of fire is just about the same as its cyclic rate. The Maxim and the Browning both had usable volumes of fire on the order of 500 rounds per minute, and both had combat ranges well in excess of 2,000 yards. The water-cooled machine gun truly was the next best thing to being there. This tremendous capability is not free. For starters, the weapons are expensive to manufacture. You can see all of the very small, yet very finely machined parts in this Maxim. Though the Browning was a good bit simpler, both weapons required major industrial investment. The crews for the weapons had to be large and highly trained. Highly trained because of the requirement for maintenance before and during firing, such as headspace, and spring tension adjustments. The crew had to be large because there were many other jobs to be done. Also, the water-cooled machine gun weighed well over 100 pounds, not counting water and ammunition. When broken down, it took at least 3 men to carry it. It also took a long period of time, 3 minutes or so, in order to get the weapon properly placed in position. You should have noted that we had 11 sandbags stacked on the Browning when we fired it. The extra weight of the sandbags helped damp out the vibrations of recoil and was a requirement if one was to take advantage of both the accuracy and the high sustained volume of fire. This does not tell the full story. Someone had to load the cloth belts with ammunition. This required a separate machine, such as this Browning cloth belt loader. The cloth belts had to be saved by one of the crew members. They were washed, dried, and then protected from mildew. They could not be loaded too far in advance, or the cloth would stretch and the cartridges would fall out. The advantage to the cloth belt is that it is much easier on the machine gun and does contribute to the overall reliability. The small beaten zone of the water-cooled machine gun translates to an extremely long adjust sight range. It was the job of the gunner to adjust sights for range and to compensate for wind drift. However, the gunner could normally not properly spot the fall of his rounds. Another individual with binoculars spotted the fall of the rounds. The vertical portions of the reticle on the binoculars that you use today are leftovers from that era. They are based on a logarithmic scale and were used for adjusting the fall of long-range machine gun fire on the ground. For the really long ranges, something over 15 or 1,600 yards, plus for indirect machine gun fire, that is, placing bullets down into a trench or into dead space behind a hill, even more equipment was required. Every crew carried a clinometer, which was used for adjusting the elevation of the machine gun in mills as specified in the firing tables. The effect of the water-cooled machine gun is common knowledge. The trench warfare of World War I can be attributed to the water-cooled machine gun along with the bolt-action magazine rifle and the new breed of artillery. Between these three, no man's land really was a place where no man could survive. As the British learned when they marched forward up the Somme, long-range machine gun fire was a force to be reckoned with and could inflict a horrendous number of casualties in a very short period of time. We need not go further into World War I, for you'll study that in much greater detail. When you do, remember what you have just seen about the water-cooled machine gun. How would you like to charge across no man's land through the barbed wire in the face of a water-cooled machine gun?